Okay, this is 8G5. This is 8th grade geometry standard number 5. And we are going to be talking about angle relationships today. Uh, in the future, we're going to be talking a lot about the transversal lines, parallel lines, similarity, and all of the relationships that you might have between angles within different types of polygons. So let's just start today by talking a little bit about angle relationships. All right, this is a very vocab heavy part of the year. When you get into geometry, you have a lot of terms that you need to know. So let's get these copied down, and I'm going to go through each one of them here in the video. Complementary angles. Notice that it's plural. A complementary angle is when you can take two angles, add them up together, and they equal exactly 90 degrees. So if I'm looking at the first figure here on the left, I have what appears to be a 90-degree angle. We don't have the box in there. I guess I could draw it in there for you. And I will tell you that this is a 90-degree angle, and it is bisected by a ray that's coming out of angle B. If you notice here where the box is, we have a ray that's coming right out here, and it's bisecting. And bi means two, like a bicycle. So we have it in two separate angles. And I can call this angle 1, and maybe the small one down here could be angle 2. I guess we could use some terminology or some notation that shows you what an angle might look like when you write it out. So I could say angle A, B, C is your right angle. So if I were to talk about the two separate angles, angle 1 would be A, B, D. So angle 1 is equal to angle A, B, D. And then angle 2 would be D, B, C. D, B, C. And what they want you to do is when you're talking about complementary angles, you want angle 1 to be added to angle 2 to equal angle 1 added to angle 2. That should equal 90 degrees exactly if they were considered to be complementary to each other. All right, so let's look at the second example on the right. I noticed they didn't put their arrows here. I'll do it for them. And we have a 90-degree angle. Notice the box here that says that it's 90 degrees, and it's bisected by this ray that's coming out of that 90-degree angle. And they give us two measurements. They say 25 degrees and 65 degrees. So if I were to quickly add those up, and it totals 90 degrees, I can say since angle 1 is added to angle 2 and the sum of those two angles is exactly 90 degrees, we can call these two angles complementary to each other. Okay, the second screen that we have here, the second type of angle that we're going to talk about are supplementary angles. And basically the rule on this one is that when you take a straight angle, you see this angle A, I guess they use lowercase, so angle A, B, C, that one going from left to right, it's the horizontal straight line. We call that a straight angle. And what we know about straight lines or straight angles is that they are equal to exactly 180 degrees all the time. So if I take ray BD, if you notice ray BD here, if ray BD bisects the straight angle of ABC, it also created two angles. We call it angle 1 and angle 2. And if you add up those angles and you take the sum of angle 1, this little acute angle in here and add it to this obtuse angle, the two of those should add up to be 180 degrees exactly if they're considered to be supplementary. And let's check the one on the right here. So if I have this angle at 120 degrees, this obtuse angle, we'll call it 120 degrees. If we were to add that to this acute angle, which is 60, if they equal exactly 180 degrees, they would be considered supplementary, and they are. So two angles added together to get 180 degrees are called supplementary. Okay, now I'm going to talk about vertical angles. And if you look on the picture on the left, I have two red lines. And if we know that we have a red straight line, I can call this line L. It's named here on the picture. So line L and line M, they are both considered to be straight lines, so they both have 180 degrees in them. So if I'm just focusing on angle 1 and angle 2, I notice from angle 1, which is my acute, all the way over to my angle 2, we have this nice arc, and it looks like a semicircle, because if I continued it on, I would have a full circle. And we know that there are 360 degrees in a full circle if I kept coming around here. So if I take a half of 360 degrees, we would get 180. And that's what we have for our supplementary angles. So let me clear that off here. All right, let's focus in on angle 1 and angle 2. We know that the sum of those are 180 degrees. 3 and 4 are 180 degrees, and if you just kind of went around the picture, you could put 2 and 3 together. You know, they kind of branch out. This ray is coming out of this straight line M, and you have a lot of different supplementary angles here. So 1 could go with 2, and 2 could match up with 3, 3 could match up with 4, and 4 could also match up with 1, and you get all of these different supplementary angles. So when we're talking about vertical angles, by rule, the angles across from each other are going to be considered to be congruent. They're going to be the same. So I don't have my my protractor out here, so I'm just going to guess. Since this is an acute angle, I would say that this might be about a 70-degree angle. I don't know, maybe 60, 70 degrees. So by rule, angle 1 is going to be congruent to the angle opposite when the two lines intersect. So we have another 70-degree angle here. And then, you know, you could use your rule of supplementary to figure out if this is 70 degrees, this angle must be 110 degrees, because 110 and 70 is equal to 180. And then by rule, angle 2 is also congruent to 4, so this would be 110 degrees. Now, add those up. What do you think they should all add up to be? Let's check it. Yep, they should all add up to be 360 degrees. There's my 6, carry the 1. So it checks out. We have a picture here that has a total of 360 degrees, and we are just showing the rule of vertical angles here. Okay, the picture on the right kind of did the same thing for us. You can see here the circle. The circle going around here would get you 360 degrees. So we have two of our acute angles at 46 and opposite 46, and then we have our remaining 134s. These are called vertical angles. All right, now I'm going to do some math with some algebra. I'm going to throw some variables in there. And it says, find the measure of the given variable in the figure. Then find the unknown angle measures. So looking at this, I have two separate angles. And if I kind of dragged this K over to the H and kind of laid it on there, these pictures would just kind of mend together here. So ray KJ would match up right on top of HI, and it would form some type of picture. Now, if I'm eyeing it correctly, it almost would look like a 90-degree angle. If you can see that, I'm not sure, but myself visually, I see it being a 90-degree angle. But if that's the case, we would call that complementary. That means that the sum of these two angles, the sum of them put together, so this is angle 1 and angle 2, the sum of them should be 90 degrees. Well, let's check that out. Let's set up an equation. So if 8r plus 9 is added to 7r plus 6, if they were complementary, they would have to equal 90 degrees. All right, so let's put our like terms together. We've been working with like terms. I've got 8r plus 7r, and that's 15r. And then we've got positive 9 plus 6, and that's 15. And now we solve for r. So the inverse operation of plus 15 is subtract 15. So we're going to end up with that 15r by itself. And 90 minus 15 is 75. We divide both sides by 15. And that is going to be r is equal to 5. All right, so solving for this picture, if r is equal to 5, I have to substitute my 5 into my expression. So 7 times 5 plus 6. Well, that's 35 plus 6, which is 41 degrees. And then I take that same value 5 and I plug it into my other angle. So 8 times 5 plus 9. That's what it says right here. So that's going to be 40 plus 9 is 49 degrees. Now, if these were complementary angles, when I add 49 degrees and 41 degrees, they should total 90. Let's check it out. 49 and 41, and it does. So we can say that these two angles, when combined together, would form complementary angles, sum of 90 degrees. Okay, picture 2, same idea, except we have a supplementary look. We have a straight line right here, and we have a ray that's bisecting our straight line. And we know that the straight line is 180 degrees, and it's broken into two separate angles, and we're going to add those together and set it equal to 180 to find out what x is. So let's do that. So 4x and 45, there's angle 1, and I'm going to add that to angle 2 and set it equal to, we know that that's a 180 degree line right here, and it bisected it. So let's combine our like terms. I have 4x and 5x, that gives us 9x. And then I have 45 minus 18. That's 27. And that should be equal to 180. All right, inverse operation again. Subtract 27 from both sides of your wall. Here's your wall. So I'm going to be left with 9x equaling 153. And what do we have here? Looks like we have a mess. Okay, so 153 divided by, where's that calculator out here? So we have 153 divided by 9, and that's going to be 17. So divide both sides by 9, x is equal to 17. All right, now let's check to see if they're supplementary. Substitute in my 17. And then again. All right. So we have 68. 4 times 17 is 68 plus plus 45. And then the bottom one, 17 times 5, what do we got there? So we had 68 plus another 17. Should be 85 minus 18. All right, just for time's sake, let's figure this out here. So we have 68 and 45 is 113. And 85 minus 18 is 67. And if I were to take my two angles and add them up, I have 113 plus 67. And that should equal 180 degrees, and it does. If they are supplementary to each other, their sum total should be 180 degrees total here. So I found the value of x. I found the value of x being 17. I substituted into my expressions. I did the math, and the two of them added together to get 180 degrees. Supplementary. Okay, the last one looks to me like we have two straight lines and they are intersecting each other. And let me throw the arrows on there. And what do we know about vertical angles? They should be equal to each other. So let's set them equal. And do our inverse operations. We bring our items from one side to the other. And I taught you very quickly, if we have a wall here, all you need to do is take your x's to one side. If you bring one over, you got to change its sign. So if we bring this 4x over to the left, it's going to become negative 4x. So we have x and negative 4x on the left. And we have negative 5 on the right, and we're going to bring this 16 to the right and make it negative. Change its sign. All right, so x minus 4, that's 1x. 1x minus 4 is negative 3x equals negative 21. Divide both sides by negative 3. So x is equal to positive 7. All right, let's do our math. Check it out. On the left angle here, we have x plus 16. So we're going to replace 7 and 16. And we're going to get what there? That's 23 degrees. So if these are vertical angles, I know that the right angle, the right side of this angle must be also 23. Let's check it. So 4 times 7 minus 5, that's 28 minus 5, which is also 23 degrees. So what did we do? We noticed that these are vertical angles by rule. We know that they're equal to each other, so I set up an equation and we solve for x and substituted once again. Okay, In your journal, define the given terms that we had on page 2 of the flip chart, and I gave you a lot of information here. This was one of my longer videos. I apologize for that, but geometry, there's going to be a lot of new terms and a lot of explanation needed. So we're going to take this into the world of transversals coming up in my next video. So please write down any questions that you might have, and let's bring those to class so we can figure out those answers.